In this video, we will discuss how do we differentiate a product of two functions if both factors are differentiable, right? You have two functions, f and g. You can differentiate f, you can differentiate g, but you can generate a new function which is a product of f and g, f times g. Whether the new function is differentiable. If that function is differentiable, how do we get the duality of that function, right? So here we are assuming f and g here are differentiable functions, differentiable, right? Sorry, that's differentiable, right? I.e. F prime, G prime exist, right? Well, if you try to write it, what's the meaning of this? It means as h goes 0, f of x plus h minus f of x over h. As h goes 0, g of x plus h minus g of x over h. These two here exist. So that's a meaning exist as finite numbers, right? So that's a meaning of two functions are differentiable, right? And okay, if you have two functions, they are differentiable, you can get a new function, which is f of x times g of x, right? Now you wonder whether this function here is differentiable, right? Now, how do we do that, right? And so let's try to develop a formula here. So this is same as, okay, this is same as h goes 0. You plug in you plug in x plus h on the product. You get f of x plus h times g of x plus h, then minus you plug in x, which is f of x times g of x over h. I want to evaluate this limit here, right? Now, how do we do that? Now you can see that we want to make a connection with what we know here, right? We know this is the first limit is f prime. Second limit here is g prime, right? And how do we make the connection here? And so this equal to, right? This is a very classic way to make the connection here, right? So we're just putting a middle term, f of x plus h times g of x plus h minus f of x times g of x plus h, then plus f of x g of x plus h minus f of x times g of x over h, right? So we put in a middle term, this term and this term. These two are same, so they cancel each other. We don't change our function. And also, after you put in this pair of terms, the first two terms, there's a common factor, which is g of x plus h. Second group of terms also has a common factor with it, which is f of x. You can bring out common factors and try to do a distribution, right? And so this is equal to as h goes to 0. Now let's do a distribution. First pair, second pair, right? First pair over h, and then you bring out the common factor, which is f, which is what? Which is g of x plus h times g of x plus h, then plus f of x times g of x plus h minus g of x over h, right? Okay, now we can use what we know, right? We know the limit of this quotient exists, which is f prime. We know the limit of this quotient exists which is g prime. We know the limit of this is g of x. The limit of this is h of x because h goes 0, right? F of g differentiable implies being continuous, just plug in 0, that works, right? So both term here has a finite number as limits, right? Both term, their limits exist as finite numbers. We can use our sum rule for limit, so the limit laws, and split our limit and take a limit, and also use the product laws, right, for the limit. So you get this equal to f prime of x times g of x plus f of x times g prime of x, right? Split the limit and take a limit, everything works. So this is our product rule. So this is differentiate each factor and keep the other one and go through all the factor, right? You get f of x times g prime of x, right? So this is our product rule for differentiation, right? And so let's see example, right? Let's see a quick example here. Example. Let's see if f of x is x times e to x. We want to find f prime of x, f double prime of x, and in general, f unstitutive of x. Let's try to do that, right? So you can see that this is clearly a product rule. We know that the derivative of e to x is e to x, right? Solution. And by our product rule, we know that f prime of x is x prime times e to x plus x times e to x prime, right? Then apply the derivative of x, which is 1, and the derivative of e to x, which is e to x. You get e to x plus x times e to x, right? And f double prime of x, right? How do we do that? This is just equal to the derivative of we want to use the sum rule, right? Derivative of the first term, which is e to x prime, and plus we want to use okay, let's use our sum rule first. So this is e to x plus, now we need to use the product rule on the second term, which is x prime times e to x plus x times e to x prime, right? And so this is same as 2 times e to x plus x times e to x, right? And you can see that whenever you differentiate once, you get a term which is e to x. So in general, you can get f the nth due to this function. This is nothing but n times e to x plus x times e to x, right? You can check it, the third derivative if you want, and this for sure works, right? Okay, now let's see another example. Now let's see another example. This is our example 1. Example 2 here is we know that f of 2 is 1. We know that f prime of x is x squared times f of x. We want to find what? Find f double prime of 2, right? The second derivative of this function at 2, right? Let's try to do that. Okay, so if you are looking for the value of the second derivative at 2, all you need to do is figure out second derivative, right? If you want to get second derivative, you just differentiate first derivative. So we are given the formula for the first derivative. Let's try to do that. So f double prime of x is basically f prime of x, then prime, right? So which is x squared times f of x prime, right? And then we can apply our product rule. First factor is x squared, second factor is f of x. So just apply the rule step by step, you get 2x times f of x plus x squared times f prime of x. But we do not know what is f prime of 2. So we know f of 2, right? So all you want to do is now plug in f prime of x, right? So this is equal to 2x times f of x plus x squared times f of x. Now we are ready to evaluate f double prime of 2. So this is equal to 2 times f of 2 plus 2 squared times f of 2. And we know f of 2 is 1, right? So this is 4 plus 16, which is 20. So this is, we can use our product rule to evaluate some function values if the information needed are given.